1907 was a time when Einstein was really basking in the glow of having already discovered what we call the special theory of relativity, material that we'll touch on a little later tonight, various insights into the nature of space and time, and he set himself around that time the goal of understanding an even bigger mystery, the force of gravity. Now you need to know, around 1907, in fact way before that, many physicists believed that gravity was pretty much understood from the work of Isaac Newton. However, Einstein was, of course, the kind of thinker for whom there was no such thing as received wisdom that he wasn't willing to challenge, willing to think through in fresh, new ways. And in particular, when he was thinking about the force of gravity that everybody was aware of and thought that we understood well, he asked a very simple and basic question that no one seemed to have the answer to. And that question was, how does gravity really work? How is it that one object in the universe, like the sun, can somehow exert a pull on another object like the earth, even though there's nothing connecting them? There's effectively empty space between them. How does gravity get the job done? So naturally, to try to answer that question, Einstein went to the Principia, Newton's Principia, which has all the results in math and physics that Newton found in his lifetime. You know, it was the book that was required reading for tonight's discussion in, of course, the original Latin. Now, of course, you know, most of you therefore know the story, but for the one or two who maybe didn't quite finish the reading, let me just carry on. So Einstein went over to the Principia. He opens it up to letter G, you know, finds the law of gravity that Newton had written down in the late 1600s, and then he goes a little further to the subheading M for the mechanism by which gravity operates. And there Einstein finds something surprising because Newton basically says, I don't know how gravity works. I've been able to write down an equation that seems to govern its influence, but if you ask me how it actually gets the job done, I don't know. In fact, in his own words, he said, to the answer of that important question, the mechanism by which gravity operates, Newton said, I leave it to the consideration of the reader. Most readers at that point would simply read on. Here is where Einstein was different. He spent 10 long years trying to figure out how gravity works, and he finally did come to the answer with his so-called general theory of relativity. And let me just quickly describe to you what he found, because it sets the stage for this idea of there possibly being more than 3 dimensions of space. How does it go? What's Einstein's idea? Well, the idea is often described in a metaphor that you perhaps have heard before. Let me describe it, and then I'll show you a visual. Forget about the universe and gravity for a moment. Instead, imagine that I have a big rubber sheet stretched nice and taut in front of me. In your mind's eye, you can watch a marble as it rolls across the surface of that rubber sheet. It goes in a straight line trajectory, nothing too weird about it. But now if I change things a little bit, I put a rock on the rubber sheet. Now the sheet looks like this. It's warped, it's curved, it's deformed. If I take that same marble, it won't go in the same straight line trajectory any longer. Now it will go in a curved trajectory because it's rolling on the curved surface of the sheet. Einstein says, take that idea and apply it to the universe, the fabric of space. Not a rubber sheet, but the fabric of space. And what would that look like? It would look like this. So if we go out into the cosmos and use this as a representation of 3-dimensional space, which is a little hard to work with, so let me do what we'll often do tonight, go to a 2-dimensional analog that we can picture better. Space, like the rubber sheet, is nice and flat when nothing is there, but if the sun appears, the fabric of space curves. Similarly, in the vicinity of the Earth, the fabric of space curves. And now focus your attention on the moon, because this is the main point. The moon is kept in orbit because it's rolling along a valley in the curved environment that the Earth creates. That, Einstein says, is how gravity is communicated from place to place. Warps and curves in the fabric of space. The Earth, too, kept in orbit because it is rolling along a valley in the curved environment that the sun creates. That is how gravity works.